Hello, students. Have you ever noticed how salt crystals from the sea glisten in the sunlight? It's not just the salt, it's the water of crystallization. So, what does this mean? Well, water of crystallization refers to the water molecules that are locked inside the structure of salts as they form crystals. This water isn't just any water, it's part of the crystal and it plays a crucial role in determining the shape and color of the crystals. When you look at hydrated copper, too, sulfate, for example, it has a bright blue color. But did you know that this color is because of the water molecules trapped within the crystal structure? As these salts form, the water molecules fit perfectly into the lattice, giving the crystal its shape and hue. When heated, these molecules can be released and the crystal changes its appearance. It's like a chemical makeover. Let's explore how water is an essential part of this process. Now, let's compare hydrated salts to their anhydrous forms. Hydrated substances contain a specific number of water molecules incorporated into their crystalline structure. For instance, copper 2 sulfate pentahydrate crystals are blue, but when we remove the water by heating, we get the white powder, anhydrous copper 2 sulfate. This transformation happens because heating drives off the water molecules. Interestingly, this isn't a permanent change. You can easily restore the hydrated form by adding water back to the anhydrous salt. This reversible change is something we see all around us, from the crystallization of salts in nature to industrial applications. Let's dive into the science behind the loss of water. When a hydrated salt is heated, the water molecules that were part of the crystal lattice break free and evaporate. These bonds are relatively weak, so the water molecules escape and the salt becomes anhydrous. In the case of copper 2 sulfate, the blue color fades, turning white as the water evaporates. This is an example of a physical change, not a chemical one, as we can always reintroduce the water to bring back the original hydrated form. The release of water is gradual, and sometimes you can see steam rising off the substance. This is a simple but fascinating process that shows how heating affects molecular structures. Water of crystallization is more than just a chemistry curiosity, it has practical uses. For instance, hydrated salts are crucial in the pharmaceutical industry. Copper 2 sulfate is used in small amounts to create chemicals for medical and industrial applications. Another example is Epsom salt, which is used in medicine and agriculture. These salts rely on their hydrated forms to function properly, as the water molecules affect their solubility and stability. The presence of water also influences how these salts interact with other substances, making water of crystallization an essential concept for understanding chemical behavior in both labs and industries. Have you ever wondered why crystals look the way they do? Water molecules are key to this. In hydrated salts, the water molecules fit neatly into the crystal lattice, providing stability and a distinct geometric shape. This organization of water within the crystal is what gives hydrated salts their physical properties like color and shape. For example, in hydrated copper 2 sulfate, the water molecules are arranged in such a way that they interact with copper ions, forming that beautiful blue crystal. The shape of the crystal, its symmetry, is due to the way these molecules are arranged. Without this water, the crystal structure wouldn't be the same. To sum up, water of crystallization is an amazing phenomenon that affects everything from the appearance of salts to their practical uses in industries and medicine. Hydrated salts are crucial in nature and lab experiments because the water molecules within them provide structure, shape, and even color. When we heat a hydrated salt, the water is released and the salt becomes anhydrous. This process is reversible and it shows us how temperature can change a substance's properties. So, Next time you see a crystal, remember it's not just about the salt, it's the hidden water molecules that are making that beautiful shape possible. I hope this session helped you see how chemistry isn't just about equations, it's the invisible force behind everyday chemical reactions. See you in the next class with more exciting chemistry concepts.